And remember, we don't explicitly test vocabulary. I mean, you don't have vocab tests in here, but when this vocab shows up in the form of a question, name this or find that, you need to know what these things are. So it's part of the reason we write them down. I don't think we need to write down what a circle is, right? You guys know that a circle is all points equidistant from one center point, yes? So every circle has a center, and we will label some stuff, okay? So you've got a center equidistant from all these points, and from the center to the edge of the circle is called what? Radius. Okay, so you have radius, and we also have from one point on the circle to directly through the center to another point would be called what? Okay, so the line going through the center is a diameter. That's the key. We're going to be talking about between this chapter and chapter 12, you're going to be learning some parts of circles, and some of the things go from point to point on a circle, but they're not through the center. So unless they're through the center, I mean, they have to be through the center to be called a diameter, okay? The diameter cuts your circle exactly in half, right? Okay. Okay, congruent circles. Have congruent radii, okay? So, I mean, obviously all circles are similar, but in order to be congruent, their distance from the center to the circle has to be the same, and their diameters would have to be the same, okay? So we're going to name these. Yep. Yes, P. So the center we're going to call P. Radius would be PC. Our diameter would be AB in this case. Okay. Keep in mind, a radius can be anywhere. You can move the radius when it's necessary. Okay, you'll understand that more later, but a radius, as long as it's from the center to the edge, I could draw a radius in anywhere and it's going to be the same length as the radius that I have. Diameter, you have infinitely many diameters in a circle. They just have to go from the edge of the circle through the center. All right, and central angle is an angle with the center of the circle as its vertex. Okay, so we actually have a few central angles. We have angle BPC, angle CPA, technically BPA, straight angle, okay, but those are central angles. One of the things you're going to be doing, I think, on the quiz test is figuring out how that pertains to like a pie chart. Okay. If we were to look at a circle, we've got kind of two pieces of information. If I were to split this up, and say, okay, you know, you've seen pie charts before, right? A circle is 360 degrees. But we can also, usually we do pie charts in percentages, right? So 100% of the circle would equal your 360 degrees. So if you wanted to say, for instance, there's one in the book and it says we spend 30% of our day sleeping and 20% working. Okay. And if you wanted to find out, I mean, if you were doing this by hand, which I know we don't have to anymore, you've got technology that does it for you, but if you're going to say, okay, well, I want to know how many degrees my angle should be to represent 31% of my day, okay? Well, you would do 31% of 360 degrees, right? Because 360 degrees is 100%. And it's probably been a while since you guys have calculated percentages, but as a reminder, percent means out of 100. So you don't do 31, you do the decimal for 31, right? So it'd be 0.31 of means what in math? Times, yep. So 31% of 360.
111.6.
What is it?
111.6.
111.6? Okay, so if you were trying to do a pie chart accurately, that angle that represents, you know, your sleep should be 111.6 degrees. All right, so if this were your 31% of sleep, that should be 111.6 degrees. Okay, so take a second and see if you could do the 20%. That would be 20% of 360, or 0.20 times 360. Should be 72 degrees, right? So if you were to figure out percentages for your entire day, how much you spent sleeping, eating, working, entertainment, that type of thing, you would want your day to be 100%. And of course, all your angles then would add up to 360 if you calculate them correctly. Okay, that's one of the things you're going to be doing. A little more vocab. Okay, if you can darken those parts or squiggle on them to note that this is what we're talking about. Okay, these are 3 different types of arcs. Okay, this one is a semicircle. Okay, well, first of all, an arc is part of a circle. Okay, this one here is a semicircle. It is basically around a diameter. It is not the diameter, but the arc is 180 degrees. Okay, so this is 180 degrees because it is half of a circle. And you know that it is a semicircle based on the diameter, right? This one is what we call a minor arc. It is less than 180 degrees. And this one is called a major arc and is greater than 180 degrees. And just like we did with angles and segments and lines and all that stuff, there is special notation, because otherwise if we just list letters, you don't know what those letters pertain to. Is it an imaginary line between 2 letters? Is it a segment? Okay, so if you are naming a semicircle or a major arc, you need 3 letters, okay? So use 3 letters to name anything greater than or equal to 180. In the case of a semicircle, the reason we need a 3rd letter is because if I just said, okay, we're going to talk about arc TS, you wouldn't know if I meant this arc or that arc, right? So if I use TRS, you know which arc I'm talking about. So the notation for this looks like this. So TRS would be that semicircle. If we're talking about the measure of it, okay, we put the little m in front, just like the measure of an angle. Okay, for this one, for a minor, you only need to use 2 letters because it's less than 180. So RS is enough, but we would say the measure of RS is less than 180 degrees. Okay, so the arc has an actual little arc over it. But if you're talking about the degrees, you put the little m for measure. And this one, we would have to use 3 because it's greater than 180. And if I used RS, you would think I was talking about this one, not that one. So we would use RTS, or you could do STR. Order does not matter as long as the end points of your arc are the first and last. So we'd say the measure of RTS is greater than 180. Okay, now you don't have to write this down, but obviously, if I have two arcs, okay, the measure of my major arc and my minor arc here, RS plus STR, should add up to 360. Okay, so we're going to talk about arc measures, but first, identification.